All right, I know the motion of the slider B. From that, given the setup, I want to figure out the angular acceleration of the wheel. Okay, so essentially I'm going to use AB as my linking. So I'm going to determine the acceleration of A equals the acceleration of B plus alpha of AB crossed with R of A with respect to B minus omega AB squared R of A with respect to B. Now, the first thing that jumps out is the fact that I need to find omega AB before I can do any of this. So what I'm going to do before I get into this acceleration equation is start with the corresponding velocity equation, and that would be the velocity of A equals the velocity of B plus omega AB, which is what I'm looking for here, crossed with R of A with respect to B. Okay, so now we're going to step through this and figure out what's going on. Okay, so what I know right off the bat is that, again, B slides to the right, which means it's pulling on A, so the velocity of A is also to the right. It's going to be tangent to that curve. So the velocity of A is just going to be in the I direction. Don't know what it is, but I know it's in the I direction. Now the velocity of B is given to me, and it is 6 in the I direction. Okay, and then I have the omega AB crossed with R of A with respect to B. And again, omega AB, I don't know what it is. I do know it is in the K direction. Not sure if it's positive or negative. I'll get a negative if I'm wrong. Okay, and then R of A with respect to B, again, that goes from B to A, so it's negative X, positive Y. Okay, and here's what I got to figure out this angle right here. Okay, and from inverse tangent, I can determine that's a 30-degree angle, right? Because I have the diameter is 10 inches, hypotenuse is 20 inches, inverse sine of 1/2 is 30. So that gives me negative cosine 30 in the I and plus 20 sine 30 in the J. Then doing that cross product, I get negative 17.32 in the omega AB in the J direction and negative 10 omega AB in the I direction as given there. So now I break this up into X and Y components, just like I always have done. So I get VA equals 6 minus 10 omega AB, and then I get 0 equals negative 17.32 omega AB. From this, I learned that omega AB equals 0. That is, it is not rotating at all. And from this, which I'll show you what we'll need later, it shows me that VA equals 6. So from this, I know then this guy goes to 0 up here because there is no omega AB. So now I'm going to step through each one of the accelerations now that I've determined what that is. Let me just kind of do that just to keep things separate. So now I'll step by step through this. Now again, I have two components of the acceleration of A, right? I've got alpha r here, and then I've got v squared over r there. Again, that's why I need the velocity of A as well. Okay, so the acceleration of point A is in the x direction. It's going to be 5 alpha in the I, and then in the negative y direction, it's going to be 6 squared over 5 in the j. Again, that's the tangential and normal component of the velocity of a. The acceleration of a. The acceleration of b is given to me. It's 3 in the I direction. Okay. Alpha AB, I don't know what it is. I know it's in the k direction, either positive or negative. So that's going to be alpha AB in the k, and then that's going to be crossed with that same r vector that I had previously, which would be negative 20 cosine 30 in the I plus 20 sine 30 in the j. Doing that cross product, I get something pretty similar to what I had in the velocity equation. I get negative 17.32 alpha A B in the j, and minus 10 alpha A B in the I. Now, I'm recognizing that I've got two alphas here. I've got alpha A, which is the one I'm trying to find, that is of the disk, and then alpha AB is of that connecting rod. Again, the angular velocity is 0, so this is all I've got for this equation. So now I can break this up into x and y components. So I have 5 alpha A equals 3 minus 10 alpha A B. And then in the j direction, I will have, what would that be? That would be 30, we'll just go, I don't have it right here, so we'll just leave it alone. We'll say 36 over 5 equals negative 17.32 alpha AB. So from this guy, I learned that alpha AB equals 0.4157. Plug that in up here, and I can find that alpha A, which is what I'm looking for, is negative 0.2314, and that will be radians per second squared. So it's actually accelerating in the clockwise direction, as shown there. So again, got to find the velocity before you do anything with regards to the accelerations.